Good morning, respected sir. I am Pujita Krishnan, pursuing my Electronics and Communication Engineering from Institute of Aeronautical Engineering. My roll number is 21951A0477. I am from section B. Today, I would like to take the privilege to present my Tech Talk presentation on the topic a survey on the privacy preserving data aggregation and wireless sensor network. So this is my topic for today in the subject wireless communications and network. So let's get into our presentation. So before getting into our presentation, I would really like to thank my department and also the faculty of the subject for giving me this great opportunity for learning this topic, to getting aware about this topic. Is it helped me a lot, sir. So let's get into our presentation right now. So let us know what exactly is the privacy preservation. So how why do we need to preserve the privacy and preserve the data aggregation? That is the main motto of this particular topic. So privacy preserving data aggregation in wireless sensor networks is a crucial concern for protecting sensitive information. Data aggregation refers to the process of collecting and summarizing data from multiple sensors in a network. In this survey, we will explore different techniques and protocols that aim to preserve privacy during data aggregation. So, this is our motto. The main aim and the motto of this is to preserve the privacy during data aggregation. So, what is the importance of privacy preservation? Let us know what is the importance of privacy preservation. Privacy preservation is essential to prevent unauthorized access to sensitive data. In wireless sensor networks, privacy is particularly important due to the deployment of sensors in various domains, including healthcare and environmental monitoring. Preserving data and data aggregation ensures the confidentiality and integrity of the collected information. So, here we come to know what is the importance of privacy preservation. So, why do we need to preserve and safeguard the privacy of a data? So, before it gets leaked, and the data gets leaked from the personal information, we will have to preserve it because there are many details, many personal details of a person or an individual or any kind of company, wherein the information has to be preserved and safeguarded always. It should be encrypted, so privacy should be more, it should be more private. It can't be leaked so easily, because if the data is leaked, then the person or the individual or anyone related to that is in risk, and their bank details, anything can be hacked easily. So in order to prevent that, there is privacy preservation. So this is why it is important. So threats to privacy: adversaries may attempt to compromise the privacy of wireless sensor networks by eavesdropping on communication channels. Data aggregation can reveal sensitive information about individuals or organizations. Privacy threats can lead to unauthorized access, data leakage, potential misuse of collected data. So, if there is any kind of misuse of the data or data leakage or unauthorized access, that is if you give the authorized access, means if you are the user and you're using it and you have kept the password and it's encrypted, only you can use it. Or the people or the users whom you have given the permission to use it or access the data, they can open it. If other someone else from other than that person has opened it, that is called as unauthorized access. So when it is unauthorized access, then there might be many kind of dangerous threats and privacy threats of this topic. So that is the thing. And privacy preserving techniques. So what are privacy preserving techniques? It is of encryption, anonymization, differential privacy, and all. So encryption, data encryption techniques such as symmetric and asymmetric encryption can be used to protect the confidentiality of aggregated data. Anonymization. Anonymization techniques can be applied to hide the identity of individual sensors or users involved in data aggregation. And differential privacy. Differential privacy techniques add noise to aggregated data to ensure that individual contributions can be distinguished. Such as we can see in the image on the right side, symmetric encryption and asymmetric encryption. One session key is asymmetric encryption, and two different session keys are asymmetric encryption. So this is about the techniques of privacy preserving. So now let us know what is homomorphic encryption. Homomorphic encryption allows performing calculations on encrypted data without decrypting it. It enables privacy preserving data aggregation by allowing the aggregation of encrypted data without revealing the underlying values. And now this is about homomorphic encryption. Encryption can be computationally expensive and may introduce additional overhead in wireless sensor networks. So this is about homomorphic encryption. So moving on to our next slide, it is about secure multi-party computation. So what is secure multi-party computation? So it is also known as MPC. That is, it enables the multiple parties to compute a function collectively without revealing their individual functions or inputs. MPC can be utilized in data aggregation to ensure privacy by securely computing aggregate functions. MPC protocols often require significant computational resources and communication overhead. So this is about the multiple party computations. That is a group of parties where they want to compute some value, a particular value, and there are many inputs and many inputs given in order to get the output. So if you get one output, you get many inputs. That is the main motto of this. So this is about multi-party computation. Moving on to our next slide. So what is randomized response? Randomized response is a technique used to protect privacy in data aggregation by introducing noise. So it involves adding random values to the reported data, making it difficult to infer individual values accurately. Individual values accurately. And randomized response can provide a certain level of privacy but may affect the accuracy of aggregated results. So this is about randomized response. So next, moving on to our next slide, which is privacy preserving data aggregation protocols. That is LEACH, HEED, and SPDA. So, low energy adaptive clustering hierarchy, that is LEACH, is clustering based protocol that reduces energy consumption and supports privacy preservation through randomized rotation of cluster heads. HEED, hybrid energy efficient distributed clustering. HEED is another clustering based protocol that aims to prolong network lifetime while ensuring the privacy preservation. SPDA, secure privacy preservation data aggregation. SPDA is a protocol that combines aggregation signature schemes with secure multi-party computation to achieve privacy preservation. Privacy utility trade-off. Achieving privacy preservation in wireless sensor networks often involves a trade-off with utility. Adding noise or encryption can impact the accuracy and efficiency of data aggregation. As we see in the graph on the right side, we'll know what is high utility and better privacy. So when there is high utility, there might be better privacy, which is synthetic data information limiting. Adding noise or encryption can impact the accuracy and efficiency of data aggregation. Designing protocols that balance privacy and utility is a crucial consideration of this context. Performance evaluation metrics. Privacy metrics evaluating the level of privacy preservation, such as information leakage, anonymity, are important for assessing the effectiveness of privacy preserving techniques. Efficiency. Metrics measuring the computational and communication overhead introduced by privacy preserving protocols provide insights into their performance. And the last but not the least is accuracy, which is the main motto of the performance evaluation metrics. So, what is this accuracy? Metrics assessing the accuracy of aggregated results compared to the ground truth help evaluate the utility of privacy preserving approaches. Challenges in open research directions. Scalability. Privacy preserving techniques should be scalable to handle large scale wireless sensor networks. Energy efficiency. Privacy preservation should not significantly impact the energy consumption of sensors. Dynamic networks. Privacy preserving protocol should be adaptable to dynamic network conditions and changing sensor deployments. So let's conclude our presentation now with the conclusion slide. Privacy preserving data aggregation is crucial for protecting sensitive information in wireless sensor networks. Various techniques such as encryption, anonymization, and differential privacy can be employed. Privacy preserving protocols like Leech, Heat, and SPDA provide practical solutions while considering the privacy utility trade off. That's the end of my presentation, sir. Thank you for listening to my presentation very patiently. I hope you liked my presentation. Thank you once again, sir.